Hi everyone. This video, this video is on generic chain reaction. What does it mean by generic chain reaction? Bermaksud secara generiknya dia punya stepsnya bagaimana. So sebelum ni, already told you that the chain reaction will consist of initiation and then propagation 1, propagation 2, and then termination step, right? And I specifically give the example on chemical reaction that will go through initiation, propagation, and also termination. And as for generic, this one is not specific. It is more on general of how chain reaction punya steps. So, apa maksud generiknya? Dia akan dalam bentuk begini, in which that, for example, dia tak bagi spesifik reactant A untuk menghasilkan B and C, and it says here that the reaction propagates by radical R, meaning that this chemical equation will go through initiation, propagation, and also termination. Sebab dia tak spesifik, so propagation dia akan menunjukkan yang the reactant akan terurai menjadi radical, molecule radical. So for example, dia sebab kata generic kan, so kat sini dia akan letak N. N means the number of molecules react in initiation and termination steps respectively. So dekat initiation dengan termination memang ada N kat sini. So dia tunjuk secara generalnya reactant A, N A to produce radical R, and then A will dalam propagation step, A will react with radical R to produce B plus C and radical R, and termination step, the N radical R to produce the to produce the product in termination step. So the generic equation just now, bila kita nak derive the overall overall reaction rate, so dia akan jadi begini. So ini tak spesifik lah, okay? Ini just contoh kalau the generic equation yang ditunjuk seperti slide sebelumnya, in which yang banyak-banyak ni dia akan to be simplified into here, in which that CHE505 ni stands for K effectiveness, which is represent this one, and also the rate order of effectiveness is also represented by this. Alright, and this is also activation energy effectiveness, which is represented by this. So kita tengok slide seterusnya, contoh yang spesifik. Okay, slide contoh yang spesifik ada dekat slide seterusnya. This one is the continuation from the previous slide, to show that the K effectiveness is represented by this. Boleh simplify kan, rate constant of initiation over rate constant of termination times rate constant of propagation times the reactant punya concentration with the power of 2. So yang ini boleh disimplify kepada K effectiveness. Okay. Alright, kita pergi ke slide seterusnya. So let's say there is a soalan, consider the chain reaction in a CSTR and it is constant volume. So dia dah beri initiation step dia apa, dia beri propagation step dia, dan dia beri termination step dia, semua chemical equation yang terlibat dalam initiation, propagation and also termination, dan dia siap beri the rate equation for each step. So soalannya, write the mass balance equations for A, B, R and X. Dia suruh buat mass balance for all species in CSTR. And then B, what is the overall reaction with respect to CA? Bermaksud kita kena cari reaction rate overall yang with respect to reactant A. Kemudian find tau for 90% conversion of A in CSTR assuming pseudo steady state. If CA0 given is 2 moles per liter, and then rate constant given here, rate constant of propagation also given here, and rate constant of termination is given here. And the last question, what are concentration for radical and concentration for X, product X dekat termination step ni for this conversion? Okay, the answer for question, write the mass balance for species A, B, R, and X in a CSTR, assuming it's constant density. So in previous video, already told you that the mass balance for CSTR is going to be the same with that of PFR, in which that kalau CSTR kita memang akan guna initiation concentration of species minus remaining of species divide by tau. So saya bagi contoh, saya just tunjuk contoh untuk species A. Dia berada di initiation step and also propagation, and both A are reactant. So bermakna kat sini you kena siap-siap tulis dia punya reaction rate lah. So reaction rate dia dekat sini Ri, which is Ki Ca kan, Ki Ca. So you buat juga untuk propagation. That's why nanti dekat sini you akan since A is reactant, so kita akan letak siap-siap negatif di sini. So this is the reaction rate dia, and for propagation negative, and this is the reaction rate for propagation. And you akan buat sendiri untuk species R, species B, species X. Alright. Kemudian soalan B, what is the overall reaction rate with respect to Ca? So kalau overall reaction rate, it's referring to propagation step. So propagation step, Rp, this is the reaction rate propagation step, which is rate constant propagation Ca Cr, dan propagation saya dah sebut tadi juga merefer kepada overall reaction. Dan soalan ni menghendaki, needs you to write the overall reaction with respect to Ca. Bermakna Cr ni you kena cari equation dia yang dalam bentuk Ca juga. So apa yang kita boleh relatekan is the mole balance for species R ni. Dan kita akan guna pseudo state approximation which is equals to 0. So yang ni ni you equalskan dia kepada kosong. So dia akan equals to kosong. Bermakna you punya first you akan dapat rate constant initiation equals to rate constant initiation darab concentration A equals to rate constant propagation darab concentration of radical kan, sebab dia adalah equals to kosong. Okay, let's see the next slide. Then daripada previous yang you dapat tadi, equation Ki darab Ki darab Ca equals to Kt darab Cr. So kita nak Cr ni dalam bentuk term Ca. Bermakna Cr kita jadikan subject of equation, So you akan dapatlah yang ini. Ni yang the previous slide you dapat daripada KI equals to KP CR kan. Okay, so you dapat term ni, dan bila term ni you akan masuk dalam equation yang ini for overall rate reaction. And then you akan dapat jawapan ini, which is dia adalah second order kinetics. Okay, next. Soalan dia suruh cari 90% conversion of A in CSTR assuming pseudo steady state if C0 is this, KR is this, little more is that. Okay, so mass balance you yang tadi you dapat untuk species A, you boleh masukkan untuk cari tau. Sebab dia suruh cari residence time kan. So bila you masukkan semua, dapatlah jawapan yang ini. Alright, then the next question dia kata apakah concentration R and concentration of X for this conversion of 90% tadi. So daripada mass balance yang you dapat tadi, mass balance untuk setiap species, and you juga ada nilai-nilai untuk rate constant yang telah diberi. So you masukkan saja dalam equation daripada mass balance tadi. So you akan dapat jawapannya. And dia just bagi tahu since concentration of B and C is equals 1.8 moles per liter from stoichiometry, we see that CR and CX are indeed small compared to the major products as expected. Sebab tu kita kata kita boleh ignore initiation and also termination step because the radical punya concentration is too small and the product for termination is also small. Thank you.